Assalamualaikum and hello to everyone. In today's video lesson, we will continue with our syllabus by looking at Chapter 5 titled Air Distribution System. In this video lesson, we will cover the first three subtopics for Chapter 5. The objectives for the subtopics are on the right of the screen. Now, as we have learned in Chapter 3, the objectives for installing an air conditioning system are to achieve desirable room temperature. Number 2, to achieve desirable humidity of air. Number 3, to provide the right amount of air conditioning to the required space. Number 4, to ensure air movement inside the space. And finally, number 5, to distribute the conditioned air evenly within the space. For a centralized or packaged air conditioning system, all these objectives can be achieved by designing a good air distribution system. The acceptable conditions for air distribution are: number 1 is the airflow feature for the distributed air, which consists of there should be no excessive draft, in other words, air motion to the users. The distributed air should not cause excessive room air noise, and there should not be short-circuiting of air. Not having excessive draft of air is to prevent bouncing of air near the walls. This can be prevented by installing diffusers with adjusting features. Excessive air noise is normally caused by airflow with high velocity and few return grills. This can be prevented by installing adequate amount of return grills and use low-level CFM supply per diffuser. To avoid short-circuiting of air, the location for return grills should not be located where the bypassing of supply air. The second acceptable condition for air distribution is the temperature distribution in the mixing and comfort zones. There should not be excessive fluctuation in room temperature, and there should be enough space between mixing and occupied zones. To prevent from excessive fluctuation in room temperature, the row of diffusers may be located closer to the outside wall to compensate extra heat load from external sources. There should be enough space between mixing and occupied space to allow the supply and room air temperature to diffuse, and the recommended diffusion temperature is 20 degrees Fahrenheit inside the space. Now, one of the main components for an air distribution system is the ducting system or ductwork. Ducting system or ductwork in an air distribution system can either be square or rectangular or even round in shape. Ductworks are simply channels or passages used in heating, ventilation, and air conditioning to deliver or remove air. The most common material for ducting system or ductwork is galvanized mild steel, because galvanized mild steel has a zinc coating which prevents metal rusting and avoid cost for painting. Other materials for ductworks include aluminium, polyurethane and phenolic insulation panels, and also fiberglass. Additional components in a ducting system are fittings. Fittings are components used to connect ductworks, which are either different in size or shape. Examples of fittings commonly used in an air distribution system can be seen in the figure given. Now, other components in an air distribution system are the diffusers and return grills. Diffusers is the supply outlet of the supply air. In HVAC drawing, the symbol for a diffuser is as shown in the figure given. Diffusers can also either be in square or rectangular and even round in shape. The air distribution pattern for a 4-way square diffuser is as shown in the figure given. For return grills, it is the inlet for the return air. In HVAC drawing, the symbol for a return grill is as follows. Return grills are normally located in stagnant zones where there is little or no movement of air. The selection of diffusers depends on these four criteria. the architectural requirement, the structural requirement, the diffusion temperature difference, and the size of the diffuser or return grill, which can either be square or round in shape. The figure in the slide shows the complete air distribution system for a space. Please take note the location for the supply air diffuser, the return air return grill, and also the location for the air handling unit or AHU for the air distribution system. Now, factors that should be considered for a good air distribution system are the available ceiling height, the HVAC system pressure, the potential frictional losses in the ducting system, the connection to the AHU or package air conditioning system. For available ceiling height, round ducts will take up more space because it is bounded by its diameter, while square ducts will take less up space because the height of the square duct can be adjusted with respect to its width. For HVAC system pressure, round ducts will not be efficient for low pressure systems, while square ducts will be suitable for low pressure systems. For potential frictional losses, using round ducts will cause minimal frictional losses at high velocity airflow, while using square ducts will cause higher frictional losses at high velocity airflow because square ducts has sharp edges at its corner. For connection to the AHU or package air conditioning system, round ducts are difficult to connect to the main duct of the air handler, while square ducts can be easily connected to the main duct with the air handler. Now, other considerations are if we choose to use rectangular ducts, try to be as square as possible during the design process. Branches from the main duct could be flexible round ducts for easy positioning in hard-to-reach areas. And finally, for return ducts, the size can be the same as the supply duct. Okay, now we have come to the end of this video lesson. We will continue with the next subtopic, 5.4, which is the losses in ducting system using the equal friction method in another video lesson. So thank you for your attention and have a good day.